Hello and welcome to Technical Utkranti. And today we'll see the third question on arrays. We had already solved two questions on arrays. It was setting matrix zeros and Pascal's triangle. Today we'll see the next permutation question. I suggest to have a look on the first two videos where you'll get the understanding of some feeling of some more array questions. Okay. So today we are going to see the next permutation problem, and let's understand what is that. We are given a sequence of digits, interpret them as a number, and we have to find the next bigger number. So for 123 it is 132, for 312 it is 321. And the special case when you get the biggest number for the given digits, then give the first permutation or first number for those digits, combining those digits. I hope the question is clear. Let's visualize the approach to solve the problem. Let's see the first example. Row 1 is the input permutation of numbers. Now, how can we get the permutation that is just bigger than this sequence? So, one brute force solution that comes to mind is that just have all the permutations of number for the given digit. So for example, if you have 1 2 3, then have all the numbers that could be formed from those digits, and then find the input, given input, and then output the next number in the sequence. But that is very bad approach to solve the problem, because if the number of digits are 10, then there could be so many numbers, and the time complexity will blow up like anything. So let's understand how the approach will be for us. The approach is to make changes on the right side of the sequence or the number to get the next bigger number. On right side because we have lesser significant digits in the number towards the right. So this thing we understand that why the change has to be looked out for in the right side. Now, if we compare the first pair of digits from right, we see that if we okay, so if we compare 1 and 4, we see that 4 is bigger than 1, and if we switch them, then we'll make the smallest change in the number and make the number bigger than the original sequence. So we are done with this. Now what if the first pair does not have a bigger number on the right? Here we see that the number on the right is smaller than the number on the left. We understand that switching these two digits will actually make a smaller number, which we do not want. So then we move to the next more significant digits and compare 1 and 4. Here we find that the number on the right is bigger than the number on the left. Now, if 1 is smaller than 4, then swapping the two elements will produce a larger number, but that will still not be the smallest larger number than the original sequence. Let's understand it by using this graph. So the first graph represents the first number, which is this. Here we had already compared the first pair and we found that it is all increasing, and swapping them does not give me a bigger number. Then we found here for the first time that okay, I found the least significant pair of digits where the number on right is actually bigger than the number on the left. Okay, now on this, so view it as a kind of mountain, and this is a peak. Here this is the smaller number, but on the right side also you have smaller digits, right? So instead of swapping this with this, can you find a number that is bigger than this particular digit. Sorry, I'm like mixing number and digit. What I mean is actually digit. So can I find a digit that is bigger than this digit but smaller than this digit over here, right? So swapping, so I start comparing from the last digit because I know that until this particular digit, it's all increasing order. So I will find the digit which from the last of this particular sequence and keep on comparing until I found the first digit which is bigger than this particular digit. In this example, the first digits on the right side, means starting from the last of the sequence, is bigger than this digit, and we see that this is also smaller than this peak. So we swap these two guys to produce this kind of a number sequence, which is represented over here 341. Now, this particular place has got its member. Now, let's look over here. We have still not got the smallest bigger number that is bigger than the original sequence. Why? Because these digits over here, these can too be rearranged, because we see that these are all increasing in this direction, which means that more significant weights are being occupied by the bigger digits. So all the digits after this particular digit will be swapped, will be reversed in order. Okay, this will produce even smaller number. Okay, so placing a bigger number over here ensured that we'll get a bigger overall number, and then swapping these helped us to small, like helped us to you know get an even smaller number. So this number will be next in sequence to the original number. I hope you got the visualization correctly. Let's just see the algorithm. So it is compare two numbers at a time starting from units place. Find the pair where lesser significant digit is greater than more significant digit. Swap the more significant digit of this pair with the least significant digit, which is bigger than itself. Reverse the order of the digits starting with the most significant digit of the current pair. I hope this wording and the visualization that we did in the previous slide will help you understand, would have helped you to understand the algorithm. And let's look at the implementation of this. So the special case I have written over here where I am just going to reverse the complete number, and here I am writing the algorithm. So here I have found the position of the last element in the list, and I am starting from the last. Here I will compare the left digit with the right digit, and if I get that particular pair, I will then compare the digit on the left of the pair with the last, starting from the last digit of the list, to find the number that is bigger than this particular number. Okay, so I am finding the least significant digit that is bigger than the digit on the left of the pair. Okay, again I'm saying that I have found the pair where left side is smaller than the left right side digit. Now for swapping purpose I have to find the least significant digit that is bigger than the digit on the left of the current pair. Then I will swap them, and after swapping I have to reverse the rest of the array, which I will do from these particular lines. Okay, so this completes our implementation of the algorithm, And let's say I have this particular array as input, or I will give the input which we have seen in this. So 4562143, 4562143, and let's execute this, and we get 4562314. 4562314. So this completes our solution. And yeah, so the lesson learned for this particular uh, question was that the brute force solutions that comes to mind are not the ones that the interviewer is seeking out from you. And there are a lot of corner cases in the problems. Um, so it is always advised to solve the problems on a platform that could test your algorithm. For example, on Leetcode, there will be hundreds of tests that run when you submit your code. So that will identify if there is a bug in your solution. So that is one very important key. As we saw in the solution for this particular problem, there were three steps, right? First, we have to start from the least significant digits, then find the pair where the left side digit is smaller than the right side digit. Then don't swap them straight away, but find the least significant digit that is bigger than the swapping digit of the pair. Then swap them. You are still not done. Then the numbers right to this swapped digit are all have to be reversed, and then you will get the smallest bigger number that is bigger than the original sequence. So the purpose of making this video was to help you understand a different variety of questions, and also for me it is a quick revision. So it is a win-win situation for both of us. So if you like the video, uh, yeah, please like it and subscribe it. That will be a motivation for me to keep making these videos much more frequently. uh, yeah, thank you. Bye bye.